again, working with classes, we're going to look at my car1 class here, which started just as a basic sketch and then was turned into a class. So I can see there's car1. Car2 does not exist yet, so let me just comment those out real quick. So car1. If we look at car1, I have the word class, and then I have the name of my class. Again, classes by convention always start with a capital letter, so it's a good practice to get into. Then I have the data that is part of my class. In this case, I have W and an H, an X and a Y, a speed, and a color property. So these are all variables that we are now assigning to this class. So we can kind of think of them also, we could call them properties. They're the property of this object. So this car has a width and height. It has a position, X and Y. It gets a speed, and it gets to be a random color. So each time it will be different. So every instance that I put of this class on screen, it gets to be a new random color. And so my data, my constructor, and my methods. I have an update and display method. My update just updates my X position, and then I check to see if I hit the boundaries. If so, invert my speed so that I'm bouncing back and forth. This car happens to only be moving in a X manner, so it's just speed because I'm only modifying X, but it could just as easily be speed X if I had an X and Y I was trying to work with. Then I choose my fill, or set my fill, and then I draw the rectangle under display. So when this runs, I first specify the type of variable. It's based on a class, the name of my class. Then I have my instance name, or variable name. And then I populate it, and the key thing we're using here is the new word. I say new. Car1 is equal to a new instance of the car_v1 class. So when we run this, you should see one rectangle bouncing back and forth on screen. It's not very exciting, but it starts to get the point across of what we're doing. So now I'm going to work on my car2 class. Car2 class does something we did not talk about last week, but it is talked about extensively in the book because it is a very important concept. So if I look at my car2 class, we'll see in car2 it's nearly identical, except that my constructor line right here has a whole bunch of arguments in it. If I compare that under car1, it says car_v1 parenthesis close parenthesis. If I look under car2, it says car_v2. And then it says int temp x, int temp y, int temp speed. So it has a bunch of arguments in it. And what those arguments are is when I make a new instance of this class, at that point, I can send a value to this class. So if I go back up and I'm going to uncomment car2, I'm going to look at car2, and car2 says I want to send a random x value. I want to send a random number for my y and a random number, I believe that was speed. A random speed for my car. So I'm sending those in. But if I look at car3, car3 just says, hey, I'm sending an x, I'm sending a y, and I'm sending a speed. So car3 will go at 10. I'm going to not use car2 just yet. We'll use car3. Car3 update, car3 display. So car1, the class just put the object there. But my car_v2, I'm sending parameters 200, 410, x, y, and speed. Now if we look in here, we'll see that I have 3 values. And those values are then where I say x is equal to the x that was provided. Y is equal to the y that was provided. And my speed is equal to the speed that was provided. And then I'll still just have a random color. The reason for doing this is sometimes when we create objects, we want some control over the properties of those objects. We want to create an object, but with a specific set of parameters. We might want to create an object in a certain location. We might want to create an object of a certain color. We might want to create an object that has a certain speed to it, or it has a certain graphic or image that it displays. So we can have one class that could handle any speed, any location, any image, any color, any of those properties that we build into our class. So then when we say, hey, I need a new object, but I want it to have these values with it, the class says, sure, no problem. Because if everything is just tied to random, well, what if I want to be able to control where it goes? So when something happens, I want it to be based on, say, where the mouse is, or based on where in a game where the player is, or we have a certain kind of bad guy show up randomly based on the health of the player. So if the player is really unhealthy, we want the mean evil bad guy to show up to really make the game rough at that point. Or maybe we water it down. So if the player's health is in peril, then we only send a wimpy adversary against the player instead of the uber boss, because we don't want to have the player just get creamed. But these are all things that we could have one enemy class in a game that we could then send different parameters to it based on what else is happening inside our program. So being able to create a class that has arguments that accept parameters is really important. Your book pretty much put double asterisk, exclamation point, another. If it could have been highlighted inside the book of this is important, the author would have done so, because you can tell by the tone of writing that the author's voice is very emphatic that you need to come to grips with this. Even if you don't totally get it, writing a function that can, or a class that can accept values is really, really important. It's similar though when we did functions last week. If I said I want a function to add 3 numbers, and it accepted 3 numbers, and then it dealt with those numbers and spit back the sum. This is kind of the same thing. I'm creating a new object with these numbers, and then it applies those numbers when it runs. So let's see. So it showed up down at the bottom. If I run it again, let's see, where does the item show up? So it has a speed of 10, which is why it's going fast. Random color, but it keeps showing up in that same starting location because I said I want a new box to show up at 200 and 400. If I want my car to show up at a random number, I'm going to comment out 1, comment out 3. So I'm now just going to do car2, which is a instance of my v2 class. It's a random position and a random speed. My speed will be somewhere between 2 and 5. Okay, so we showed up at the top. Do it again. Let's see where it shows up this time. Well, that was kind of lousy random. Okay, but a more dramatic speed change. So each time it's going. Now, if that speed is just not really dramatic enough, we could give it a much bigger range. So we could have things that could be fast or could be really slow, as we see fit. So constructing a class that takes these parameters as arguments and then puts them in our constructor and then can use them. That is a very common little bit of programming. In the beginning, it can feel very foreign. It can feel awkward of the, okay, why or how am I using this? But when the need arises, I want you to go, oh, I remember something about this, and then you can go back and find this file and go, oh yeah, that's how it's done. One more word on this before I move on is these arguments that I have here, they are essentially temporary variables. Thus I use the word temp in my naming. But I do need to specify what kind of object they are receiving. So my temp x, temp y, and temp speed are all getting, in this case, integers. So when I did it hard-coded with car3, I sent integers to it. Those are integers, they're whole numbers. If I sent fractions, then I would get an error message about my types don't match. It'd be like, no, you gave me a float, but I'm looking for an integer, so I hate you now. And it gives you all kinds of scoldy messages, and you're like, no, I'm trying to be nice here. So it feels like it's a lot of extra typing, having to specify what kind of object or value it's receiving, but it also prevents you from being lazy, because the fact that you've now had to specify what is temp x, what is temp y, and what is temp speed as far as the kind of object they are means then you know that they're matching up to the variables that you're assigning those values to. So that's really important. And you may think, well, if I get this temp x, can't I just refer to it everywhere else? And it becomes a scope issue. Temp x, temp y, and temp speed will only be available inside kind of this set of curly braces. So if down here I said temp x, it would go, I have no idea what you're talking about. That's a scope issue. It wouldn't know. That's why we have to then create inside the class a set of variables that we then assign the values to. So it's kind of like one extra step that it'd be nice we didn't have to do that. It'd be nice if I could just say x comma y comma speed, and then it now knows, but that's just not how it works. And this concept of passing these parameters to arguments and working with this is a very standard part of programming. It happens in all languages, and it's something that will get used frequently. So don't be afraid of it. All right. So in the using arrays file that we have open here, that you can go grab off D2L if you haven't already, I have a few instructions at the beginning. I'm going to come back to those. I've now created an array. And within this array, we've now specified how big the array is going to be, and then we go and populate the array with a bunch of objects, and we'll look at how that works. And then if you thought that using loops for flag day was a great use and couldn't imagine that there would possibly be a better reason why we would want to use a for loop, now we're going to discover why we like to use for loops and how they really become nice. Because as we look at this, I now have inside my project where it's going to put 50 of these cars on screen, and then this is the car class, and this car class, car v2, is identical to car v2 from the using classes file that we just looked at. So it's identical. There's nothing changed there. And currently it's going to put 50 of those cars on screen. So when I run this, I should see 50 cars show up on screen, and there they are. Now if I want to have 500 cars, I just add an extra 0 in, saying I want my array to have 500 objects instead of 50, and then I run this again, and we will see that as it runs now I have 500. Now, I think some modifications might be in work that I might want to modify my starting position so that they're a little bit higher on screen. Let's see, my whole project is 500 tall, 700 wide, but the cars themselves have a size of 100. We're going to change that shortly. So if we say x of 10 to 700, yeah, well, 690 would be, well, not 6,900. 690 might be a little bit better. And then my height, we're going to start them at 10 and 390. So starting everything within 10 pixels of the edges of the screen. So we should see a little fuller. Whoops, I'm off on my math there apparently. Oh, because they're not 100, they're 50 wide. So it would be 440. They're not 100 by 100, but they're, so now everything started. And now they're going back and forth and back and forth. And once they're all going, it creates a nice little pattern on screen. It's kind of fun. And it's exciting. And now we're going to figure out how we're using arrays to do that. So I'm going to switch it and just have one object. Because whether I have one or if I have 500 doesn't really matter. We have one. So the way that we can think of an array is just simply a collection of objects. Arrays are able to be a collection of strings, like names. I could put all of your names into an array. So it's a list. I could have a set of numbers inside an array. So it's a collection of numbers, like your grades. Put those into an array. So it's just a list of similar type items. That's all an array is. So when I have this list, I have a few things I can do to it. I can access any item inside that list, or in that list, by recognizing it has a position, because the first object inside my array gets to be at position 0. The next thing I add to my array gets to be at position 1. The next object in my array is position 2. That's how arrays work. So computers like to start counting from 0, not 1. Arrays start counting or designating their positions at 0. 0, 1, 2, 3, 4. So if I have 10 objects in my array, the 10th object is at position 9 because I started counting from 0. But an array is just a list of objects in a sequential order. And we can now access those objects in a sequential manner. And that is why we will use for loops for doing so. So the syntax for an array is I designate what kind of object is going to be in my array. And then I use these square brackets to say, hey, by the way, this is going to be an array variable. And then this is my variable name. So when your variable is an array, do not forget those square brackets. Notice I'm trying to be nice, put a little comment up here. Remind you, don't forget the square brackets when you're creating an array variable. Then when you populate that, you say that variable, cars, is a new, and we're saying it's a new array filled with the car v2 type of object. Now personally, I question why when I say this is a array variable and had to say what's in it, why do I have to repeat that again? I don't know. That's how the language is, so deal with it. Tough love. Just deal with it. Suck it up. And no, that's how it is. So we specify the type of object in the array twice. Once when we create the variable, and once when we then populate that variable with content. Now, I again use square brackets, but this time I put a number in it. 1, 10, 100,000, whatever. And that is how many objects are going to be in that array. Now, processing needs to know the same way that you have to say if a variable is an integer, it goes, oh, it's an integer. Well, I know I need this much memory to store an integer. Well, when it's an array, it needs to go, okay, how much memory do I need for each kind of object in the array? So we have to tell it what kind of object. And it needs to know, well, how much memory do I need anyway? Because if a car takes up so much memory, I need to know how many of those car class thingies you're going to put into that array. So we have to tell it how big my array is going to be when we construct it. So processing requires us to, 1, specify what goes in the array, and 2, how many of that what are going to be in the array, so it can now allocate the correct chunk of its memory to store those items. That's why it requires us to do that. So we just have to recognize that is the syntax. Create your variable using the type of object in square brackets, then your variable name. And then you say that variable is a new, and then you once again specify what kind of object, but this time inside the square brackets, how many of that object will be in my array. That is the base syntax in a nutshell. All right. So if I look here where I say, let's just pretend this is just, whatever. It doesn't matter what that is. But it says it's a new car v2, and then we send a bunch of numbers to it. If I go back to my previous file, you'll see, oh, look, that looks just like this right here. It's a new version of that class. So this is a new version of that. But this time I said cars, square brackets, put the letter I in that. So when I'm using a for loop, what I'm doing really, we're going to hold off on that because I'm going to go back and just say my array is 1, and I'm going to just comment this out so it's less scary. If I say cars, square bracket, 0, square bracket, is equal to new car v2, and then I can just go 100, 100, 10. So I have now populated the one and only object in my array with my new car. Because I said cars and then square brackets. You may be noticing square brackets are used excessively when you're using arrays. That's what they are. Curly braces are used in functions. Square brackets are used in arrays. If you ever decide that coding is your lifeblood and you realize that you are just destined for coding and you love writing code, and it gets you all giddy and you lay in bed at night thinking of cool coding algorithms, and you decide that square brackets are cooler than the curly braces, then you might want to learn Objective-C, which is the programming language that is used for iOS devices. So Objective-C is a superset of the C language, and it uses square braces instead of curly braces for most of its work. So if the square braces make you happy, then you can go learn Objective-C. I find I'm a curly brace kind of person, so the square braces, I like them for my arrays, and that's it. So I'm not going down that road anytime soon. I find that if I bounce between too many languages simultaneously, my brain gets addled and confused, but it could be a sign of old age. So square braces are excessively used for arrays. We use them when we designate an array value or variable. We designate when we construct that array, and then when we want to access the element in the array. Now I said I want the object at position 0. That is going to be the first item in the array. If this instead of 1 was 2, then I would say cars, square bracket, 1, close square bracket, is equal to new car v2, 200, comma, 320. So now I've put 2 objects in my array. My array can only hold 2, and I now put those 2 objects in. Now if we notice, this number starts at 0 and then is always going to end 1 less than however many objects are in the array. Well, that special property of arrays is referred to as length. What is the length of the array, or the length of my list of items? So if I have 10 objects in my array, my length is 10. But their positions are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's kind of important because we can now use that to our advantage. And we'll look at that. Or you may notice the stuff that's commented out is actually using that magic word called length. So if I have car 0, car 1, like this, and if I run it, we'll see it works. We'll get our 2 objects showing up. And if I run it again, they will show up at the same speed, the same place, but different colors because their colors are random, but their other properties are fixed as it's been passed to them. But I've now put those two objects in my array. I'm going to come back to this one up here in just a moment because it doesn't fit nicely on one line. It's easier, I think, to look at it down here. So inside my draw function, we can see that I'm using a for loop. Again, that thing that was horrible on Flag Day, but now we actually have a legitimate purpose to use. Because now I can say, well, we'll start I at 0. Oh, look, my array likes to start counting at 0 too. That could be important. Then I say I is less than the length of my cars array. Well, if the length of my cars array is 2, we could just right now, I could hard code in the number 2, and it would give me the same result. And then I will increment by 1 each time we go through it. So then the first time through my loop, I say, in my cars array, at position 0, oh look, 0, let's update that car. Okay, that's cool. And now we'll say, oh yeah, and I's still at 0, so cars, position 0. Yeah, we'll tell that object, why don't you update yourself or display yourself? So it updates and displays. It runs through and does its methods. So we're able to access the object inside the array, which is super cool. Because when we start building more complex projects where we'll have bullets and raindrops and aliens and asteroids and monsters and zombies and whatever your imagination develops and brings into the project, we will have multitudes of those on screen, and we need to keep track of them. We will use an array to store those objects, and then we will use a for loop to cycle through those objects and access their update and display methods that are built into those classes. So this allows us to access the objects in my array. Now this section up here is, otherwise this will be ugly if I don't do that. This is the same thing. I starts at 0, length, I++. And now we say the first object in my array, well, at 0 is equal to a new car v2, and we put some random numbers into it. And then it loops through again, because it's going to go through, I started at 0, then I becomes 1. 1 is less than 2, so yep, we can go again. Populates the next one. Now I becomes 3, or let's see, 0, 1, 2. And so let's see, so once it becomes 2, okay, that's cool. I is less than 2. Well, 2 is less than 2. Nope, that's no longer true, so we won't execute this code. We move on and go do something else. So that's why it populates it. So remembering that I starts at 0, then it runs through this code, then I goes up by 1, plus plus. 1 is less than 2. We can run the code again. Now I becomes 2. 2 is not less than 2. So we don't get to run this code anymore. So that's why we're able to take advantage of arrays like to count from 0, and the length of the array is a super awesome magic number. And because I didn't hard program in that number, then when I say 20, I get 20 of them. When I say 2,000, I get 2,000. You can see it's a little bit less happy at this point running, but it's still kind of fun. All right, so through a lack of dissent from Claudette, I am going to add her minions here. And what I will say is minion, square bracket, minions will be my array. So we don't need these original ones. Comment those out. Don't need those there. And now what I can just simply say is minions is equal to new minion square bracket, and now I can choose however many I want to put into my array. So if I even start out with, we'll just do an even 10 to make sure it doesn't totally crash right away. Then and then do a for loop. So I'll have my for loop. So minions is equal to a new minion, and there will be 10. My for loop, int I equals 0. I is less than minions dot length. Now, for many years, I resisted this concept of using a singular and plural naming convention because I felt they were too similar in my code. And in recent years, I've found it to be good because then when I see the name of my array, minions, I know I don't have to look at the code to know what kind of objects are going to be in it. So if I had a bird class and then I wanted to have a whole flock of birds on screen, I would refer to that flock of birds, that array would be called birds. So my birds class would be filled with my birds array would be filled with my bird class objects. So that singular versus plural naming convention, I used to find troubling because I'd look at it and, oh, they're too similar. But now I like the fact that if I see the plural, I know what kind of thing is going to be in it. You just have to make sure you spell it correct. I ran into a problem where I had bullet and bullets, but then I forgot the double L in one of them. So then I ran into all of these issues where classes and arrays were just not happy with each other, and I couldn't find it because on a quick glance, 1 or 2 L's in bullet looks the same. So that was my own stupidity at work there. So now what I can do is say minions, square bracket I is equal to a new minion. And that now puts it in. Now we don't need any of that because now we will use another for loop under my main draw and say for and I hit a key by accident there. I hit 0 instead of tab. And now I can say minions. And we'll just cycle through this. Update. Minions dot display. So realistically, if you take your homework from last week, add in these 2 for loops, add in your variable for the array, you can now go from 1, 2, or 10 objects that you had on screen up to, we'll start with 10 here because the minions are fairly complex, and we'll chug it up a little bit. Now I have 10 on screen. But if I decide that 10's just not enough and I really want to see things get chunky, and I'm going to just close out the frame rate line here so it can go as fast as it's capable, because even at 100 minions it's still going to go slow. But now with 100 on screen, we can really see that there is variety in both eye color and pants color because there's enough close in proximity to each other. But 100 of these is now starting to have some issues moving as part of it. That's okay. But what we have proven is that it's possible with fewer lines of code to now have a near unlimited number of objects on screen, which I think is pretty cool.